lot of people have asked, can this preamp be used as a headphone amplifier? Well, the short answer is yes, it can. I've been delaying replying to the people that have asked that question because simply I didn't know. On paper, it clearly can be because it has a low impedance output and it's able to deliver a fair voltage and also a fair current, which is what headphones need basically. And obviously the lower the impedance of the headphones, the more current they require. Not something I'd recommend you do. You can actually drive a small loudspeaker directly from the output of this preamp. Please don't do it because it will make the output transistors pretty warm, and it's just something that it just gives you an idea as to its current and voltage capability. But I'm not suggesting for 1 millisecond that you connect it to a pair of loudspeakers and expect to get any kind of power at all. But it does get surprisingly loud. Don't do it. Not a good idea. I know you're daring me to show you, aren't you? If this goes bang, it'll be your fault. Well, that's probably the silliest thing I've done for some time. I still think must be crackers. Things I do for you guys. Just so you know, and again, I must say, please don't do this because it's not a good idea. That was a 4 ohm speaker and it was a piece of YouTube friendly music. I think we can deduce from that it will drive pretty well any load for a pair of headphones, but generally I wouldn't use less than 32 ohms. The current demand for such headphone would be quite high, and it seems to do it, and it didn't get hot and it didn't go bang. We tested this, or Ron I should say has tested this with 2 pairs of headphones. One is an AKG and they are 130 ohms, and he said that the detail you can get from this preamp with headphones is absolutely phenomenal. And the other pair he tested, which are, shall we say, less quality, which happened to be 32 ohms, again he said you could get levels, clean sound, way above what was really safe to listen to long term. So yes, go for it. Before you go and connect your headphones to it, you need to make sure DC offset is pretty well 0. Bearing in mind that headphones have a very, very small and lightweight voice coil, and it could be fairly easy to damage or burn the coil. I would suggest that you should be below 5 millivolts. Here's where you need to measure across these 2 terminals here, and it's switched on, as you can see by the LED, and the volume control, which you can't see, now you can, is set to minimum. That's purely so you don't get any signals, and obviously you don't want it connected to anything. You want to be able to measure less than 10 millivolts. So I'm going across one channel now, which happens to be the left, and it's 1.2 millivolts, well 1.1. And the other channel, this channel is half a millivolt, virtually nothing. In fact, it's minus 0.6 of a millivolt. Another question which has cropped up on a number of occasions is DC amplifier. In other words, if you put any DC into the preamp, it will amplify that and output it straight into your power amplifier. That is not good. You don't really want to do that. If you could put capacitors on the input and the output, it wipes away the fact that it's a DC amplifier. Well, that's really true. Let's say you're going to feed it with a DAC or a CD player or anything that you have, or even a radio tuner, if you remember what one of those is, or even worse, a cassette deck. Most of these products will have a capacitor on the output, possibly because they're not DC amplifiers, so they will be naturally AC coupled, and the way you do that is with a capacitor. The same can be said for the output of the preamp. Should something go wrong with the preamp or its power supply, instead of putting out the 1 or 2 millivolts that you've just seen, it could theoretically put out many volts. This leads me to the second point. Your power amplifier, again, is probably has a capacitor on the input, mainly to stop people doing exactly what we're talking about. Most components tend to put out a couple of millivolts of some sort of DC. If there's any doubt in your mind about your amplifier, obviously if you've built it yourself or from a kit or whatever, you know if it's got a capacitor. But if there's any doubt, you need to fit one. Simply because if your amplifier is DC coupled and your preamp, if something goes wrong on an external input, it'll go through the preamp and it'll go into the power amplifier, and you're going to have much DC on the output. So you can imagine the consequences of 5 or 6 millivolts on the preamp. Time that comes out, that could be 5 or 6 volts, and time that goes into the amplifier, I mean, it will just put horrendous amount of DC right across your speakers. What capacitors to use? Let's say you've decided to use one on the input and the output. Your amplifier is still a DC amplifier, but you don't want to amplify any DC. You only want it to amplify AC. On the output, the preamp is very low impedance, as you've seen by this silly test that I did. So if you're going to couple that to your amplifier, which could be anything between low and high impedance, you're going to need a relatively large capacitor if you don't want to get bass roll off. In an ideal world, you'd use a non-electrolytic capacitor of the numerous types that are available. You really need a capacitor of about 47 microfarad if you want to maintain the exceptionally low frequency response. It won't affect the high frequency response, but it will affect the low frequency response. So a 47 microfarad polystyrene or any of the more exotic capacitors, apart from the fact they're going to be huge physically and very expensive, I would suggest you don't do that, because the difference between that and a so-called audio grade electrolytic is minimal. It really is. I know that there's going to be people jumping up and down saying, no, it's going to destroy this and it's going to destroy that. Well, if you feel that strongly about it, get a bank loan and go and buy one of these very expensive capacitors. I would suggest you use a bipolar electrolytic, but one made for crossover networks, or a so-called audiophile capacitor, and they tend to be labelled as such, and they tend to be that fraction more expensive. For those of you that don't know what a bipolar is an electrolytic capacitor that you can put either way round in the circuit, hence bipolar, 2 poles. So it doesn't matter which way round you put it, as opposed to a standard electrolytic. Put that round the wrong way and you get the magic smoke. So don't do that. You might as well also use the same capacitor on the input. This slide shows you how to make your own bipolar capacitor. Now, to make a 47 microfarad bipolar, you will need 2 100 microfarad. Now this will actually make a 50 because there's no standard value to make it, which is fine. And you need to connect it as shown in the drawing. The 2 positives are on the outside and the 2 negatives are linked together on the inside. Now when you put capacitors in parallel, the capacitance doubles. So if you put the 200s in parallel, that would make a 200 microfarad capacitor. But when you put them in series, it halves the value. So your 2 100 microfarad capacitors will become 150 bipolar, which is just what you want. And they're small and they only need to be rated at 25 volts, low ESR and so-called audiophile. But if you can get a bipolar to start with, they only cost about 10-15% more than a standard capacitor, and you've solved the problem. Let's talk about potentiometers. I think everyone will agree that a logarithmic potentiometer is probably the best option. The question is, what value pot should we use? So we're going to look at the effects of different value pots ranging from very low, 20k, right up to 100k. The following slides show the preamp used in the lowest gain mode, which is basically resistor 11 replaced with a 1k ohm, and the gain then is somewhat substantially reduced. But it does give you the textbook best performance. Always use the minimum gain that your particular amplifier or circuit requires. Saying that, worst case, it's going to be brilliant and wonderful response, beautiful straight square waves with minimal slew rate. This first slide shows the out-of-the-box fitted capacitor of C8, which is 100 picofarad, is the one with the minimum gain using the 1k resistor. 4 different value potentiometers. The best frequency response is with the 10k. The second slide shows what happens when you replace C8 from 100 picofarad down to 47 picofarad, which is the value I have suggested in previous videos. Even with the worst case pot of 100k, it's still only half a dB down at sort of 30k. Generally, I would not recommend using a 100k pot. The minimum should be 50k. This third slide is purely just for information. I don't know why you'd want to do this, but this is replacing the capacitor C5 with a higher value of 220 picofarad, and you can see there's a noticeable roll off. Dare I say, if you like the valve sound, this could be the way to do it. You can clearly see it's 1 dB down at about 20k, worst case. So if you don't like the extra HF, or you don't think it makes any difference, then this can be your answer. On the next video, I'm going to show you how to use a little power module. It enables you to connect this preamp or any other preamp that uses this sort of relatively low current, how you can connect this to your main power supply of your amplifier. and it's suitable for up to 75 volts. It only needs one rail and it will give you an output of 15 volts, 0-15 exactly, and I'll show you how to make little module and how you can connect this directly to the board, and in fact any other board, and it will work with virtually any amplifier because the input voltage can be as low as 30ish and as high as 75. More details in an upcoming video. Thank you for watching, much appreciated as always.